Okay, in this question we've been asked to find the set of values of x for which fx is a decreasing function. Well, let's just think what a decreasing function would mean, first of all. So looking at this, we have some cubic function. Let's not worry exactly what it looks like at the moment, but a negative cubic will look something like that. So if we look at this and we think, well, when we say a function is decreasing, we tend to think as we move along the x-axis, is our function decreasing, means is it going downwards, i.e. does it have a negative gradient? So in this sketch, which is probably not a very good sketch, we would say this function is decreasing for all of these values here. In between, it has an increasing. It's an increasing function. So I would need to find this set of x values. Any sets of x values which are less than that given number or more than that number, which we'll find, we know that our function is decreasing. It has a negative gradient. So let's actually have a look at the algebra now and try and get ourselves a good picture of what's going on. So the fact it's decreasing, and we related that to the gradient, tells us that this is a differentiation question. We're going to use a different notation. F dash means the derivative of fx. Basically it means the same kind of thing as dy dx. The only difference is we weren't told that this was y equals, we were just told that this is fx. Different notation means exactly the same thing. We've differentiated this function. So let's do that. Minus 3x squared plus 30x minus 63. Again, the constant, we just lose it. And we want to know, where is that derivative less than 0? Where is it decreasing? Technically speaking, we would say less than or equal to 0, because when we say a function is decreasing, we mean that if we stepped a little bit to the right, we would go down. Similarly, if we stepped a little bit to the left, we would go up. So even if it happens to be 0 at one exact point, if I went to the left, I would have to go up. So we do technically use less than or equal to in this case, but don't worry too much about the technical reasons why. Okay, so we need to solve this quadratic. So it's a quadratic inequality. We're going to be revising lots of stuff that we've done previously. Good practice, we should make our quadratic term positive, so bring it over here. Remember, we do that by adding and subtracting. We don't do that by multiplying by -1, because that will change the way the sign faces, and that's an easy thing to forget. So we're going to pick all of these terms up and move them over here. So that's going to give us 3x squared minus 30x plus 63. And now we notice that everything here divides by 3, so we can make our quadratic a little bit easier to factorise. Factors of 21, which sum to 10, 7 and 3, so that's going to give us that. So our key values, if we just do a little sketch now, would be x is minus 7, x is minus 3, x is 7, x is 3. And we're looking for where is this quadratic greater than 0. Those sets of x values. So we're looking at x is either less than 3 or x is greater than 7. Relating that back to the sketch of the cubic we were originally asked about. Let's just clear this from the previous videos. That tells us now that we can do a better sketch of our previous function. We know that our function is decreasing all the way until x equals 3, when it must start to increase until x equals 7, and then it decreases again. So we can use this idea of decreasing or increasing functions to find where our gradients are negative And if we looked at the other side of the inequality, where this was greater than 0, we would find where our function is increasing. It can help us get much better sketches, and it can help us understand behaviour. Perhaps we're using this to model some sort of population. We would definitely want to know whether a population is increasing or decreasing. That could inform our decisions for conservation or animal management or environment management a great deal. This is an important area of maths.